Hello, my name is Devon Gonzalez, student ID 2305778. This is limits of a function. What is limits of a function? It's what the value of a function's output gets closer to as the input value approaches a certain point, in disregard to the actual value of the said point. And as a math major, limits of a function relates to me because it's an important calculus concept, and calculus will be both studied and used plenty in my math career. Starting off with this problem, as we try to figure this out, and we're going to start off with direct substitution. We're going to figure out pretty quickly that it's not going to work because plugging 0 into the bottom h right here, it's not going to work out because we always know that 0 divided by 0, or just anything in general divided by 0, is undefined. So we know that's not going to work. So we're going to do the next best thing. Okay, start off right here. Alright, so we're going to multiply this to the top and bottom, but with an addition. Plus 2 over the exact same thing. And with this, we understand that a minus b times a plus b is equal to a squared minus b squared. So with that being said, we could do this pretty quickly and just transfer this over to this right here. And we take this (15h plus 4 squared minus 2 squared. And we're going to simplify that. This right here, because we have a radical right here, is going to get simplified to simply 15h plus 4. This right here, 2 times 2, is going to be simply like that. Then we can simplify this even further, because we know 4 minus 2 is going to be 15h plus 2. All right, pause it. Start now. Actually seeing this happen though, I did make a quick mistake, and this right here should be instead 15h plus 4, because 2 times 2 is 4. Sorry. So that was a simple mistake, but we fixed that real quick. And we know, of course, this and this simplifies, so we're going to be left with simply 15h. And so this is still just this top right here, just the top. And so we still have h times this right here, this and this. We still got to multiply these two. So finishing this off, we got 15h at the top, all over h times the other side. Alright, so continuing in this right here, we see this pretty quickly, is that we got an h right here and h right here, and we could cancel those. So this will simplify to 15 15h plus 4 plus 2. All right, so now that we have this right here simplified, we got to remember exactly what we're doing here, and we're trying to find the limit as h approaches 0. So now we're going to take what we originally were doing, put this back over here, now that it's simplified. So this is what we're trying to find. Value of the limit as h approaches 0 of this said function right here. Now, we're going to simply plug our 0 into it using substitution. All right, let's see. 15 times 0, 0, plus 4, take a step further, keep simplifying. 0 plus 4 is 4, plus 2, going further. This right here is going to become a 2. Then we're left with 15 over 2 plus 2, 15 over 4. So this is what we get to right here. And again, this means the limit of h as it approaches 0 of our original function is going to be 15 over 4. So again, our limit as h approaches 0 of this function is 15 over 4. All right, our next one of the limit as x approaches -4 of the function x squared plus 2x minus 8 all over x plus 4. Now again, direct substitution is not going to work right away because we know if we plug in the -4 here, -4 plus 4 is 0, and again, we know that's not going to work. So we're going to look, we can see we can factor the top. So we're going to factor this right here. Let's see what we could do using the factoring method. We're going to see that, again, what can we get to get -8? That also goes together to get 2. So we're going to think we could try out -4, 2. Nah, let's try out 4, -2. So, damn, why did I struggle with start? Alright, so 4 times -2 equals -8, so that's good. And 4 minus 2 equals 2. So this is going to work. So that means that it's going to look something like this right here. And again, the bottom part, x plus 4. So, alright, so we see we got this right here and this right here. So we can simplify this. You know, take these out. And we're left with x minus 2. Alright, now going back to what we're doing, we're trying to find the limit as x approaches -4. With this, you can write this back out. But I simplify the function. Alright, so now we're able to substitute. It's pretty easy algebra. negative 4 minus 2. Pretty hard, pretty hard. All right, we got this, negative 6. And again, that's going to get us to our conclusion that the limit as x approaches negative 4 of our function x squared plus 2x minus 8 over x plus 4 is equal to negative 6.
Start.
Okay, so with this right here, we gotta understand one thing, and it's that we this is related to a whole different function, the sine of x over x, and we're gonna, and knowing this right here is equal to 1, because it looks a little something like this on the graph right here. It looks a little something like this right here. So again, that's what it looks like on the graph, and just know that this right here is a closely related function, okay? And we also want to remember one more rule, and it's about constants. This is a limit law right here. The limit as x approaches a, c of x, c of f of x is equal to c times the limit as x approaches, a of fx. Alright, we're gonna keep these two things in mind right here. So we're doing okay, so again, with this, let's remember that this has a relation to this right here, sine of y over y. The only thing is we're gonna, in this situation, relate this with y is equal to x, because obviously this is sine of x over x. This is using a variable with y. All right, that's cool. And we're gonna need this limit law for later, not right now. So first things first is we're gonna try to get this simplified similar to this right here, because we know this function right here is equal to 1. At least that's what the limit is. So coming back to this, all right, we see this 19 right here, and it's stuck inside, and so we're gonna leave it that way, but we're gonna utilize this, and we're gonna multiply the 19 from to the top and the bottom. We're gonna be left with 19 times sine 19 of y. Oops. And I completely forgot there's a 4 right here. We're going to separate it like this right here, but it's all the same thing at the bottom right here. Now, that being said, this simplifies 19 and we want to move one thing out so we can make this the same at the bottom, the 19y. We want the same at the bottom, so we're going to divide everything, the whole thing, by 4. This whole problem by 4, and we see that this cancels out right here. Move this sucker over. We're going to be left with 19 over 4 times sine of 19y over 19y. And now we got this to where we have a constant right here, and we have this the same in the middle, and we're gonna somehow get this, relate this limit law back to this right here. Now let's remember what we're doing again is we're finding the limit as y approaches 0. So we got this right here. Okay, that's cool. Now, here's the thing. Knowing this right here, we're gonna be able to move our constant, which is this right here. We want to move this out because knowing our limit laws right here, we know that this could be moved out of this scenario. 19 over 4 times our limit scenario, which is and we know that these right here, these 19s, they cancel out. Oops. So we're left with this right here, and we're gonna go back to what we remember at the top right here, is that this is gonna be equal to 1. So we actually know, carrying this over 19 over 4, we understand that this part right here is equal to 1. So we could plug that in as 1, quite literally. And we know 19 over 4 times 1 is 19 over 4. And so that gets us to our conclusion that the limit as y approaches 0 of our function sine of 19y over 4y is equal to 19 over 4.